Hello, hello. I hope your day's been swell. Here we have finally the fourth episode of Let's World Build. And I say finally because, as you can probably tell, it's been a little bit since my other video, and that is because I have been quite busy over the past few weeks. But going forward, I should be a lot more available, so these videos should be coming out a lot quicker. I want to have the fifth episode of this series out within a week of this one going out, and I want the proper next episode of the world building showcase out as well. So, but enough of that intro sort of stuff. Let's just get into this episode, since I want this one to be pretty short, pretty nice and sweet, because we've got some really simple stuff to do in this episode. But first, let me get up this my notepad here, and you can see that I've added a couple of things. The first one is to stop rushing, because I feel like I definitely made some, not necessarily mistakes, but it's kind of clear that I was definitely rushing in the last episode. I do want to take my time a bit more with these episodes, do my due diligence, do my research, stuff like that. So that's a note there. The other thing that I just completely forgot to do for some reason was I need to add an age to the galaxy. The age of the Milky Way is wrong. I'm going to change that to around 10 billion years, and I'm actually going to make this galaxy 9 billion years. Did we never gave an age to the universe either. This is an arbitrary number, but I'm just going to say 14.8 billion years old. Since we're going to be working with several billion year timescales, I want to nail down an age for when the intelligent beings are going to come around. And I'm actually going to clarify that here as well as I'm just going to add some funky little decimals, because why not? 9.43. At the birth of intelligence. Alrighty dighty. And then the next thing in these notes, the dust ring that I was describing earlier is actually called a dust lane. And dust lanes have a lot of new star formation because, it's a bunch of dust. It's going to be coagulating and coming together due to gravity, and then that's going to create a whole clutch of new stars. So I'm actually going to say generally older stars away from the dust lane and newer stars within the dust lane, which does match up with the research that I did. So that's pretty good. So that is all the notes that I have for now, and we can get into new things, which is very cool and nice. Okay, so the immediate thing that we're going to want to do is create a new stellar system, and I just call them astral systems for simplicity's sake, or I guess for categorization's sake. It's a useful term because that also includes planet moon systems, stuff like that. And there is a lot of argument that I should maybe start with the star cluster that surrounds the astral system that I'm going to create, but that is not especially important to the actual, the system itself that I'm going to be spending most of my time in. So if I need to do it later for, constellation reasons, for like a civilization, then I'll do that. But for now, I'm just going to get right into the astral system because, to be honest, I'm kind of impatient that way. So I am just going to get right into it. So what am I going to call this system? I've already been very generic with the galaxy, so I kind of want to be a bit more creative with the solar system name, even if it's not going to be the final name, because there's obviously going to be languages that the intelligent creatures create. So let's think of something. I'm thinking the Deca system, and this is something that I thought of in the moment as I was thinking of the name, but I want to have 10 planets in this solar system. I want to have a couple more than we have in our own solar system, just to make things interesting, have some cool dynamics there maybe. yeah, we have our system. I need to grab my templates, and I need to get an astral system over here. Create that, drag it into the correct folder, copy all of that over. I don't need this template there anymore. And now change the tags. What is the most general thing that I can say about this system? This system has a single star with 10 planets around it, one of which has life. I think that's a pretty good description. It's a very bare description, but you know. And this system here is a stellar system because that is what this is. It has a star in the center, so I categorize it as a stellar system. There's not really too much to do right now with this because I want to start with the star itself, the central star. And I'm actually going to make that not plural since it's just one star. And then I'm going to figure out the other regions in the next episode and all of the planets and stuff like that. I may as well just start with the central star, which I do have to think of a name of. You know, a lot of world building is thinking of names of things, and most of the time I enjoy making names of things, but if I don't already have a language to work with, it's very difficult because, you know, you just have to make up placeholder terms all the time, which is hilarious, of course, but it's what we have to deal with. I guess it probably helps to imagine the sort of star that I'm thinking of in the first place. So I'm actually going to head on over to the Worldsmith. And this is a tool made by Artifactsian, as you can see here. It is a very, very good tool for world building, and I'm actually a few versions down at this point. It has a whole ton of different options, as you can see here. Most of it has to do with astral stuff, space stuff, with like planets, galaxy stars, stuff like that. I actually didn't use it for the galaxy itself. Well, and this is mostly because I'm working with a very atypical galaxy, so there's a lot of this stuff probably isn't going to be the same. If I eventually make a star cluster nearby the home system, then I'll be using this setup here. But as it is right now, I'm not going to need that. So yeah, but we have here a star tool, which I'm going to use right now. In fact, if you couldn't already guess that. And I won't go too much into the descriptions of these things because Artifactsian does a lot better job than I could since he's the one that made it. So I am just going to explain as much as I need to. First of all, the editable boxes are the blue boxes that I have highlighted here. And all the rest of the stuff, if you try to change those, it'll mess up all the other squares and all the other formatting. So it's not a very good idea. The equations don't really like it when you mess with those ones. This M sol is solar masses, if you couldn't already guess that. So do I want to have a smaller star or a bigger star than our own sun? I kind of want to have a slightly larger star. Not too much bigger, but just slightly larger. Not so big that it's any form of giant, but just to make things a little bit different. So I'm thinking maybe like 1.26, something like that. It makes it a lot wider. Earth-like life is still very possible. And actually, what happens if I make it a little bit bigger? If I make it like 1.5, suddenly no more Earth-like life. And as you can see, the star's light starts getting blue, which is because the temperature's higher, and I assume that that's not very good for life. There is a habitable zone, but I imagine that as the star gets more massive, it's going to get more volatile. That happens a lot with like subgiants are very, very variable. They have a lot of fun things where they have huge spikes in their luminosities, which is not very good if you want to have a system of life. So I'm actually going to revert back to 1.26. Life is a lot more possible now. And of course, this doesn't mean that if this box says no, that life is an impossible, especially since I got magic going around as well. But I think that this is fine enough. And this age box is going to be how old it is at the birth of intelligent life. So I'm thinking I kind of want it to be a bit older than Earth's sun, so I'm going to make it 4.7. And that doesn't actually change any of the values. I mean, this maximum age just means that it's not going to be exploding into a giant star just yet. It still has like 300 million years, which is plenty of time for life to be running around. And as you can see, it has a radius that is a bit larger than the sun. Its luminosity is actually 2.5 times the sun's luminosity, which is just its brightness. Density is a bit lower. Yeah, all these fields, I'm just going to copy over the relevant ones that I have in my template into this one. So now that I have a bit of a better idea what this is going to look like, I'm just going to go ahead and name it. I'm deciding if I should be sort of funny with it or be a bit more serious than the other ones, than the other names that I've thought of so far. Actually, I'm going to stick with the naming system that I've established here, which is I'm going to just name it the Deca star since it has 10 planets orbiting around it. Kind of basic, but, you know, I think it sounds kind of cool. So I am going to create this page now. Come on, go on up. And I'm actually going to go ahead and create a folder for the Deca system since there's going to be a lot of stuff in here. I mean, there's going to be 10 planets, so I don't want to crowd out the universe folder. Where's a star template? There's a star template. Copy that over. Change the tags. Y'all already know what's happening. Alrighty, and now we need to do the very broad general section. The Deca star is a star that houses 10 planets, 2 asteroid belts, and many, many smaller bodies. And this is a very basic description, and I actually might add a bit more. And it is slightly bigger and older than the sun. I don't actually have a reference for the sun yet, but eventually I probably should make that. It isn't really useful here though because I'm not making a copy of the sun. So first order of business is adding the location, which is the central body of the Deca system. And I'll add the galaxy as well. And something that I think I forgot to do actually is that I forgot to add a location to the Deca system in the main galaxy of Universe K. And of course you don't have any planets yet. So there are 10 planets and then dwarf planets, stuff like that. I really like to categorize things like this. Way over categorize things. But let's go back to the Deca star. First of all, I want to copy the data from this. So let me just do that real quick. So the mass is 1.26 solar masses. It has a radius of 1.141 solar radii. Shape isn't really useful because it's very obviously a sphere. Generation is an interesting question, but I'll get back to that in a moment. It is around 4.7 billion years old at the birth of intelligence, and I will actually add that to the system as well, since the system is going to be basically as old as the star. They are very well linked. The density is 0.849 solar densities. It's around 85% the density of the sun, and I will use that to write in the volume in a moment, but first let me get the other stuff. So this will be surface temperature, not the temperature of the entire star all the way throughout, since cores are always way, way hotter than this number. So yeah, surface temperature is that, and then absolute brightness. Fun fact, absolute brightness is not the same as luminosity, and there's a calculation that you can do to get from luminosity to absolute brightness. But for now, I'm just going to put down the luminosity just for simplicity's sake. Yeah, let's add the class. Let's add the type of it. F4.5V. And, oh yeah, I'm just going to do the volume real quick. It's a very simple calculation. I'm literally just pulling up my phone right now. 1.104 solar volumes. So one final thing to grab here is star color. As you can see, it's very white, but I do need to grab the actual data here. So just go up here, and then you can look at the color itself, and you can see that it is F8, F7, FF. Okay, so that's a lot of Fs. Well, which makes sense because it's white. Where's my color field? I'll just put it in appearance. So color is hash F8F7FF, which is a slightly bluish white. It's like very, very slightly bluish. I don't know if you can tell from the recording, but that's what it looks like to me at least. I'll add that it's an extremely slightly bluish white. There's really only a couple of more things that I need to do for this star until I'm done. Generation. I believe the sun is around a 3rd generation star, it's believed. And actually, I'm going to look that up and make sure, because I don't want to make any assumptions. I don't want to be rushing through things. Okay, yeah. Just looked it up and basically confirmed that scientists believe that the sun is a 3rd generation star, so I'm just going to stick with that. Well, the theory is that, there are heavy elements that can only be made in supernovae. I believe you can only make up to iron in normal solar fusion, so you need a supernova to really compress those elements together and create stuff like lead, uranium, silver, gold, all those heavier elements. And it turns out that 3rd generation is pretty good for what we see on Earth. There's a lot of details here that I do not have the data and the means to fill out right now. It would be cool to go back and figure this stuff out later, but I'm just going through the very basic motions right now. There's some stuff in the motion category that we can do. Okay, so I'm actually going to delete all of these things from this specific note file, because the star itself is going to be moving with the system, so I'm just going to put all that information in the system file. So I'm just going to say same as the Deca Systems motion, so refer to that page for that. And then really the only other thing that can be done is rotational period. I believe the sun rotates once every 11 days, if I'm correct. I'm referencing that right now. Okay, so it's more like 25 days. I don't know how much it changes with the size of the star, but I imagine just due to angular momentum, the bigger the object, the slower it will rotate. So I'm going to say that it rotates once every, so around 30 Earth days, and then all of the satellites will be listed eventually. We'll get there. Surface gravity and escape velocity can be done later if needed. Composition is really simple, actually. It's mostly hydrogen and helium, because that's literally just what a star is. It's mostly hydrogen. And actually the amount of helium is very low unless it's an older star, which this is actually kind of an older star in its life, since it's only really supposed to last in this stage until 5 million years old. So it only has 300 million more years, but it's still mostly hydrogen, I believe. Tilt is a weird one, since it's not really applicable, since whichever plane the star is rotating in will be the same plane that most of the planets are going to be orbiting in, just because that's how solar systems form. So I'm actually going to delete all 3 of these fields because they don't apply to this star. There are no bigger bodies for this thing to tidally lock to or have tides with. So that is done. Now, stellar activity is actually something that I can fill out. So stellar activity is something that will be relevant to life, since, if a star is very active, then life is going to find a harder time living. I'm going to do a little bit of research right now, and then I'll get back to this. All right, so from what I've been able to find, the only types of stars that have a large amount of flares and mass coronal ejections are red dwarfs, have a lot of flares and the like. There's also types of variable stars called Cepheid stars, but those are fairly rare as far as I'm aware. And also like giant, subgiant, protostars, supergiant stars. All of those have a lot of activity, but this star is none of those. So it's safe to assume, I believe, I hope, that all of these are around the same as our sun, which isn't to say that they that this sort of stuff doesn't happen. This stuff obviously does happen with our star, but just to a lot lesser of a degree than these other stars that I've been mentioning. So I'm just going to say... So for flares, it's around the same as the sun, and well, all of these fields are around the same as the sun, but for flares specifically, they're not going to be large enough to affect planets in the habitable zone very often. There might be more like aurorae around the poles, stuff like that. Mass coronal ejections are around the same as the sun, so around once every couple hundred years, I believe. The last one that happened for our sun was in like the mid-1800s, I think. And I believe scientists are saying that we have another one due in like within the next 100 years or something like that. So nothing disastrous. There's no inherent magic holding the star together. And these two fields I'm just going to leave blank for now since they aren't relevant yet and I would need to do some research to figure out exactly how those would behave. And the rest of this page is just all the other stuff that I've gone through before. Yeah, history stuff, creation, stuff like that. Creation is very easy. I'm actually just going to go ahead and fill that out right now. So it formed from a cloud of gas and dust after it all coalesced and ignited into a protostar, which is all natural processes. Pluralize that. Yeah, very typical, nothing magical, nothing funky going on. Oh, and also, you might have noticed all of this stuff. Why are all of these things listed in a page about a star? And this is just for any sort of situation where, I don't know, maybe there's animals that are hardy enough to live on a star. You know, fantasy and science fiction is boundless, so may as well prepare for as many things as I can. Which is also why you see me deleting a lot of things a lot of times, because, you know, I just want to prepare as much as I can. So that is it for this episode. Next episode, I'm going to finish out the Deca system and really get all of the general stuff ironed out that I can. So look forward to that. And then future episodes, I will be fleshing out like the planets and all that fun stuff. So yeah. I will see y'all next time, and here is the Reliul segment.